All right. Good evening and welcome to Master Talker Online class. So let's continue with motion. We have done solving motion with formula. Let's talk about solving motion with graph. Okay. This is why I said displacement time graph. In displacement time graph, it is obvious from what the name displacement then time. Okay. This is displacement in meters and then time in seconds. Okay, this is displacement time graph, and they say that what an object starts an object starts from rest and covers a displacement in a time t. Okay, the graph is shown below. Look at the graph here. It starts from rest and move this way. Okay, and covers, this is the displacement is covered s. Okay, and then the time is covered, this is the time t. Okay, so now and that is that. So if you remember that speed over time is what, and so displacement over time is what, velocity. So the slope of this, I call it the slope of this distance time graph. Okay, the slope of this distance time graph is speed or velocity. Okay, or velocity, in fact velocity, because it's displacement not distance. So we have that the slope, please, the slope is equal to the shape of what you are seeing. If you look at this place now, this shape A, okay, the slope is equal to what, area of shape A. Okay, and if you look at this shape A, is a triangle, so it is what, 1/2 times the base from here to here, which is t, times what, the height, which is what, s. So that is it. And the slope of this thing is called what, the velocity. So the velocity v is equal to what, 1/2 times t times s. So is anytime you are using graph, okay, the slope, okay, the slope is equal to what, the sum of the total area that you are having there. Okay, so in this one I'm going to have in number 2. Let us draw that. Look at number 2 now. Look at number 2. Okay, and this was a velocity time graph. So I'm having velocity here and I'm having time here. Okay, remember that velocity is in meter per second, velocity in meter per second. Okay, and then time in second. Now listen very well to see how to draw this. They say that an object accelerates from rest. This object started from rest and moved up. Acceleration means moving up. Okay, and he moved up to a point and stop. That is the velocity he used. Okay, and then moved with a constant velocity or uniform velocity. Okay, or continues in the same velocity. It means you are going to move in a straight line like this. Remember, acceleration means move up. Uniform velocity or constant velocity or the same velocity move means on a straight line. Then remember, then finally retardation means moving down. That is the only thing you can get. Okay, so they said a body starts from rest here, accelerate, moves up, then use a constant velocity, you move on a straight line, then move down. Sometimes they can tell you that a body starts from velocity 20. You see, it did not start from rest, so you start from this velocity 20 here. Sometimes they will tell you move on a constant velocity. You know that from that 20 you are going straight line. Okay, look at it now. Let me show you another thing. Watch. But before I finish that, let me finish this one, then I'll show you different pattern which this question can come from. Now they say that a body move with an object accelerate from rest. From here, acceleration means you move up. Okay, you trace to the side of velocity, right v, trace to the side of time, write your time. The time here is what, t1. Okay, and then they now say that if the body continues in a uniform velocity or constant velocity means velocity on a straight line, you move on a straight line, then you do what, you trace down to your time. Okay, because we are still using to this side, I cannot trace again. I'll trace time to my time. The time they gave me is what, t2. I will not write t2 here. I will say t2 plus the former t I'm having. So it will be what, t2 plus that t1. So that if I say this t minus this one, I'll be having that t2 in the middle. In fact, here is 0. This one minus this one is t1 in the middle. Okay, you see how I'm doing it now. then before this man decelerates or comes to rest or retard, they say that but finally come to rest, so he now came back to rest. This place is red, that's 0. Okay, that is your T3. You will not write T3 here, you will say that T3 plus the T2 plus the T1. Okay, in fact that T3 plus the last thing you are having here, as simple as that. The T3 plus the last thing you are having here, so that everything here minus this one here will give you that T3 in the middle here. You see how to draw this? Okay, so then what they say you should find, permit me to clean here to write what they say we should find. Now the only thing they can ask you to find here, they can ask you to find the acceleration. This is the acceleration and this is the retardation. Okay, the retardation means minus acceleration. So if they ask you to find acceleration, acceleration is what? Just the velocity here over the time here, that's all. Velocity over the time. But if they ask you to find retardation, minus acceleration is from this side. The velocity here, in fact this is the initial velocity, or let me show you the best way to get it. Watch me now. For acceleration, to get the acceleration is what? You know acceleration normally is v minus u over t. Don't forget the formula, which is what? V is the final velocity, which is this one I'm having here, v, minus initial velocity. It started from 0 all over what? The time is this one I'm having here, t1. Okay, if they say we should find retardation A should be what? From this side. Retardation is what? Don't forget the final velocity minus the initial velocity over time, and the final velocity here is now 0. See that the final velocity is 0 because this is started from here and came down to rest. So the final velocity is 0 minus initial velocity now is where it started, which is this v, all over the time there is what? T3. You see, so that is that. Okay, so the next thing they can ask you to find, is the total distance covered. The total distance covered, total distance. Now the total distance covered is the area of all the shape you are seeing there. If you look at the first one, this I have shape A, shape B, and shape C. You see that? So the total distance covered, this one moving from here till it comes here, is area of shape A plus area of shape B plus area of shape C. And if you look very well, you see that shape A is a triangle. So I'm having 1 over 2 base times height plus this one is a rectangle, base times height, plus the last one is a triangle, 1 over 2 base times height. So what do we have? 1 over 2 times, what is the base? You see that you have the base here to be T1 times the height is from here to here, which is your V, okay, times V plus base here is T2 times your V plus 1 over 2 times the base here is T3 times your height what? V. As simple as that. These are the only things they can ask you. The next thing they can ask you is the average velocity. Okay, the average velocity means the total distance over the total time. That's the last thing they can ask you here. So the last thing they can ask you, let me clean here. So the last thing they can ask you here is average velocity or average speed. The average velocity is what? The total displacement. Let me call this displacement because I'm using velocity. So it will be, but let me use speed since I've used distance. Average speed is what? The total distance all over what? The total time. So, and the total distance is gotten from here after doing all these things. While the total time is this time I'm having here. That is T3 plus T2 plus T1. In fact, anything you are seeing here is your total time. Anything you are seeing at the last here is your total time. Okay? So that is that. So the next thing is to solve some question. Okay, let me tell you some kind of question you are going to get in this velocity time graph. Let me show you another pattern of question. Okay, Now look at this thing. You can have a velocity time graph like this, and they will decide to tell you that this body did not start from rest. This body maybe started from velocity of 20. You will start from here, and then when this body started from velocity of 20, this body still maintain this velocity. It did not accelerate. This body moves with the same velocity. Okay, this body moves with a uniform velocity of 20. That's how they started it. The body moves with a uniform velocity of 20. You see, I started from here. I didn't start from rest, and I moved on a straight line because I had what? Uniform velocity. Then I said, then for the next 10, maybe 2 seconds, you trace to the time of time and write your 2 seconds here. Are you getting it now? Then I said that after which this body now accelerates, I have to move up. You see how my shape is going? The body now accelerates. After accelerating, the body still now accelerates to a velocity of maybe 10. Velocity of 10. I will not write 10 here. I will say 10 plus this, which is what? 30. So this minus this will give me that my 10. Are you getting it now? Then, after the acceleration, this body still moves with a constant velocity again. Constant velocity again. Okay? Sorry, after this thing accelerates for the next, let me say for the next 5 seconds. So you trace. You will not write 5. Instead of writing 5, you write what? 5 plus d, which is what? 7. So that this minus this will give you the 5. Because as they are giving you the velocity, they must be giving you the time. So then I said, after the acceleration, this body now moves with a constant velocity again. Okay? Constant velocity again. In the next 2 seconds, you come down again. You will not write, instead of writing, you say what? 9 plus 2, which is 7 plus 2, which is what? 9. So that 9 minus this will give you that 2 that I'm talking about. They can now tell you before this body will now brought to rest in the next maybe 3 seconds. So 3 plus this will give you 12. So that this minus this will give you 3. You saw how I drew this thing. So now, another thing they can ask you, the acceleration is this side, the retardation is this side. Okay, retardation is minus acceleration, but the total distance covered, you have to be very careful, please, to get your shape so that you don't make mistake. Cut this one because this one already look like a triangle. So the shapes I'm having here is what? The first shape, shape A, shape B, shape C, shape D, and shape what? E. This one is what? Rectangle, rectangle, triangle, rectangle, triangle. You see, it's very simple to draw. You get your answer. Okay, you get your answer. Another way they can start again, let me show you another way they can start. Okay, another way they can start is like this. They can equally say that what? A body starts from it not start from rest. In fact, this body accelerates with a velocity of 20. They started with velocity of 20 and they said acceleration. So from here, I'm accelerating. You see that? And then move with a constant velocity, and then brought to rest, You see that? As simple as that. You see how this one is? Very, very simple. But you have to be traced. Don't forget, if you trace this one, you trace this one. See, this one has gone this way, you trace this one. So how many shapes do you have? You have to cover this side so that your shape will be shape A, shape B, shape C, and shape D. You see that? That's another pattern they can start with. Then the last pattern you may have, is for instance, maybe the body start from rest, move in a constant velocity, and then they stop there. They can give you something like that. They stop there. So I'm having only 2 shapes. You did not retard, and they ask you to find. So the shape I'm having here is A and B. So know what you are supposed to do. Whenever you hear acceleration, move up. If you hear constant velocity or uniform velocity, move on a straight line. If you hear retardation or brought to rest or deceleration, you bring it to rest. These are the only things you need to know for this velocity time graph. So what we are going to do is to solve questions, different pattern of questions on velocity time graph for you to understand it very well. So the first question we are going to solve, let me check my time. Okay, the first question we are going to solve all right. The question said a car A car starts from rest. Okay, a car starting from rest accelerates uniformly. This is accelerate uniformly. Don't confuse it with uniform velocity, please. Accelerate uniformly, it must go up and attain a speed of 80 meters per second in 30 seconds. Okay, it maintain. They now use the word maintain here instead of saying constant or uniform. They say it maintained its speed. Okay, it maintained this steady speed for another 30 seconds. For another 30 seconds. They say it then slows down uniformly until it comes to rest in the next 40 seconds. Okay, the questioner said calculate the uniform acceleration. Calculate the uniform acceleration during the first stage of the journey. Then I said that is for I calculate the retardation IV the average speed of the car. Okay, so these are the things they say we should find. So first thing we do is to draw it. So let us draw it. Now drawing it is very simple, just like this. Now they say that a car starts from rest. This is zero, this is rest, and accelerates uniformly. This is acceleration. Okay, with a velocity, this is velocity time graph. With a velocity of 80, so here is 80. In the next 30 seconds, you trace down to time and write your 30 seconds. This minus this, 30 in the middle here. Okay, it maintained the speed, it maintained it for the next 30 seconds again. Would I write 30 here? No, 30 plus this one I have was 60. So that this minus this will give me that 30 again. Okay, before it then brought to rest by another 40. Do I write 40 there? No, 40 plus this will give you what? 100. So this minus this will give you that 40. You see, very simple. What shape do I have? Shape A, shape B, shape C. You are done. Case file closed. Number one question said acceleration V minus U over T. And my V is what? Final velocity is 80 minus initial velocity is 0. All over what? 30. So what do we have now? 80 over 30, which is what? 8 over 3. So A is equal to what? 8 over 3 meter per second square. That's all. The next one say retardation. Retardation is what? V minus U over T, which is my final velocity is now 0 because the thing from here came down to rest. So the final velocity is 0. Initial velocity is now that 8 where it started from. Okay, all over. The time there is 40. This is the time there, 40. So what do I have now? Minus 80 over what? 40, which is what? Minus 2 meter per second square. So the retardation is what? minus 2 meter per second square. So the retardation is 2 meter per second square, but the minus shows that it is what? Retardation that you are calculating. Okay, so the next thing we are going to calculate is what? Average speed. The average speed. And I told you that average speed is what? Is simply the total distance over the total time. As simple as that. The total distance over the total time. So how do we get the total distance? The total distance. Total distance is equal to area of shape A plus area of shape B plus area of shape C. So area of shape A plus shape B plus shape C. So what do we have now? Shape A is what? Half base times height plus base times height, because this is a rectangle, plus half base times height. You are done. So what do I have now? 1 over 2 times the base here is 30 times the height there is 80. Okay, plus the base here is 30 and the height is 80, plus finally 1 over 2 times 40 is the base here times the height is still the same 80. So let us do the math. This take care of this is 40. This take care of this is another 40. So what do I have? 3 times 4, 12. 1200 plus 2400 plus 1600. So what do I have now? I have 16 plus 24 plus 12. So I'm having 52. 5200. In what? In okay, the other one is in meter per second, in meters. Okay, so now the average speed is equal to what? Total distance over what? The total time, which is what? 5200 divided by the total time is the last time I'm having here, which is 100. So I'm having what? 52 meter per seconds. As simple as that. Okay, so thank you very much for watching. I will give you more questions to solve on the comment section. God bless you.